All right, so in this, what you guys were asked to do is look at page 13 and 14 of M2. And we've talked about the idea already that slope and the common difference are the same value. But what we want to do is we want to look at other forms and try to determine, hey, how do we know if something's a linear function? Because we've already said that an arithmetic sequence is the same thing as a linear function. So one of the strategies that we can use is called the first difference. So it's taking immediate y values, finding out what those differences are, and finding the x values, and hopefully those intervals are going up by 1. If the first difference is the same, then that means that my relationship is linear. So like we have two examples that you guys have already looked at in regards to the chair comparison. We've looked at an arithmetic sequence. We've looked at the function notation. So if I look at the first difference, or if I look at what is the difference between 34 and 42, I am adding 8 to each term to get the next term in the sequence. And then if I look at the term value, or the term number, sorry, it is going up by 1. So it looks like each of these are consistently going up by the same value. They're going up by 8 every time for the arithmetic sequence. If I look at function notation, it appears the same, that each of the y values are increasing by 8 and the y values are increasing by 1. So, determine the differences, and we've done that. In both cases, the term values and the x values are increasing by 1. The term values are increasing by 8. So, what I want to do is I want to be able to look at someone's comparison in which we had Park and Ava, and this is on page 14. Park claims that the slope is 5. Ava is claiming that the slope is -5. If I look at this table, it does look like Park is taking 22 minus 17 and 17 minus 12. Now that is 5, but remember we're trying to figure out the slope is going to be what do I have to add to 22 to get to the next term of 17? What do I have to add to 17 to get the next term of 12, and so on? So I would say that Ava Kate is the best answer of -5, because the x values are increasing by 5, but the y values are actually getting smaller. They are decreasing by 5, so the slope is -5. At the bottom of page 14, you guys were asked to determine if something was linear or not. So in order for it to be linear, the difference between my y values has to be consistently the same. So if I look from 12 to 15, it looks like I'm adding 3 here, but then I'm adding 6 here, and I'm adding 9 here. So in this case, the first difference is not the same, so my sequence is not linear. If I look at B, it looks like my difference between 18 and 14 is -4, and that consistently happens between my y values. So the first difference is -4. That means my slope is -4, which means that it is linear. And then if I look at this scenario, C, that is not an example of a linear function, because in this case I am adding 3 to get the next y term. I'm adding 5 to get the next y term. I'm adding 7. In order for it to be a linear function, my difference has to be the same value. Hopefully this helps out, guys. If you have questions, don't hesitate to ask.